Good afternoon, everybody. I trust we are doing great today. Thank you for joining us again. Today is day 3 of the session with Itayo. So I will hand over to Itayo this time. Itayo, over to you.
Awesome. All right. So programming basics. This is going to be a very brief, or not brief, it's going to be a very basic level programming so that I don't confuse people too much, hopefully. But just to recap, last time what we covered was what a prototype was, the need for minimal viable products, Unity layouts, prefabs, all that. Let me just reopen the presentation so I can skim through just to give a proper recap. So it's the definition of a prototype. It's a way of testing the simplest form. We learned how to install Unity and everything. I was going to ask, did people manage to download these properly from last time? It's not like 100% necessary for today, but I'm just wondering if people were able to. You can also type in chat if you want. Up to you. Yeah, we just talked about the layout, like hierarchy, inspector, all that good stuff. Right. So today, we're going to be talking about what an IDE is. We're going to cover different data types, so variables. We're going to talk about if statements, switch cases, functions, and then what object-oriented programming is, and their pillars, essentially. All right. So what's an IDE? An IDE stands for an integrated development environment, and it's simply something that lets you code. It's probably the best way to explain it. You can even use like Notepad or any other sort of text editor to write code. It can literally be anything, but the reason why I recommend something such as Visual Studio Code is that it has a lot of very useful tools, basically. So I'll give a very brief overview. So essentially, instead of all the text, let me copy this code, basically. So instead of all the text just being black and white, it kind of color codes everything for you. So like you can see like the colors of the variables properly. You can see where the functions are, stuff like that. Very useful program, not too difficult to use. Let me see if I can put the program in chat for those that didn't see it. In case you have a 32-bit system, because I know some people had that last time, there's also an option for that, as well as pretty much every single operating system. Okay, but from there, I'm probably going to explain how you even add an IDE to Unity. Let me just open it up again. I know when you're installing Unity, there's actually an option to install an IDE with it called monodevelop, which is pretty okay. It's usable, but I do highly recommend using something like Visual Studio Code. Just wondering, is anyone able to download the program I linked? Or are you going to use Notepad? Either option's fine, but again, I highly recommend using Visual Studio Code. Vincent, are you on a computer right now? Oh, Mr. Ade just joined back. Okay, I think he was on a system. Good afternoon, Mr. Adewoye. Can you hear me?
Yeah, good afternoon. Good afternoon.
Are you able to download the program I linked?
Yes, I do, but I'm not with my laptop now.
Okay, that's fine. You can just follow along later then. Okay. So while that's still loading, I might as well show off a bit about what this does. So let me actually make a new file. Yeah, let me just make a new file quickly. All right. Just typed. I'm here, but not with my laptop. Okay, that's fine. I'll probably just type and people can follow along. All right, let me just, I'll do it in here. So basically, Visual Studio Code, it color codes everything. It kind of organizes the text properly, so it's not just like, you know, one line of things. Makes it just very clear and concise. There's also the option to add various extensions to the program. So personally, I've installed a few for Unity, which basically just makes it a lot easier to work, basically. So it kind of makes everything kind of sync together a lot better. I won't go too much into detail, but it's just very, makes everything very convenient, essentially. If you do end up downloading it, just search for these extensions on this search bar. So just search debugger for Unity, and it should come up here, and you just press install. So that's what you do if you want to get it laid out exactly like mine. Don't need to, but I do highly recommend. All right, I think this is open now. All right. Just reloading everything. All right, cool. So we're back in our program from last time. But the first thing I need to link is the IDE. So what you do, you go edits, preferences, external tools, and then you select it from here. If you're using Notepad, just click browse, this PC, programming files. And I'm pretty sure it should be, yeah, just here. So you can actually have it as Notepad here. So what that does is when you, let's open this. When I open this script, it'll actually open Notepad and open the code for us, just so that we can edit here. And then once we save it, it'll actually like appear in Unity, like the change to this script. I think I'm blocking it a bit, but you can see that's the same code, essentially. Okay, let me switch it back to my other text editor. Okay, awesome. All right, so let me actually talk about programming, or just variable types in general. So what's a variable? A variable is a data value that can be changed. It can literally be anything almost. So it can be like numbers, text, logic, which I'll explain what that is later. It's also possible to make your own variable types, which can be made out of other variables. Can make it very complicated, but for now, just know that variables can be represented as a number, text, and a logic statement, which basically means true or false. So the code I'm going to be using today, you can actually just copy from here. It's not a big download. I'll show you what it is. One moment. It's only this amount of text. So you should be able to just select, copy, and paste it into your program. You could also re-download the whole project, because I did make some updates from the original download link, but either option's fine. So anyway, variables. Let me unblock my presentation. So there are many variable types, but most important are integers, which are whole numbers. So just quite literally 1, 2, and 3. Decimals, 3.245, and then strings, which is just text. And then logic in programming are called Booleans, and they can either be true or false, no in-betweens, essentially. So what does that actually look like in Unity? So if I start off with integers, you can make a variable by typing int q. So all we're saying here is we have an integer and we're calling it q. And we can set its value to 1 if we want, essentially. For now, I already have 2 integers called x and y, which I will be messing around with now. So let me just close these. All right. So why do you need variables in the first place? So let's say you want to do some sort of mathematical function, right? Let's say you want to know what 2 plus 2 is. So you can do that. But the issue is every time you want to change what you're adding together, you're gonna have to type that in every single time. And it can become a very, very annoying to deal with, actually. One thing, I forgot to add the script to the actual, there you go. Yeah, it can be very annoying having to type it in every single time. So variables, so you can see how it just spit out our answer here. Variables just allow us to store it and like use it for later, basically. So let me actually make use of that variable. So let's say x is 3, and let's say y is 4. So what we can do is say x plus y. By the way, ignore all of this for now. Just focus on this line. So what this does, just to explain, is say to the console, spits this out in here, basically, just so that we can like see the result visually, basically. So what happens when you do x plus y? You should get 7, hopefully. And as you can see, we have an issue. It's saying x plus y is 0. So why is it doing that? Well, that's because here we've made it a public variable. So in Unity, when you say something is a public variable, it simply means you can edit its value in the inspector tab. So what does that mean exactly? Let's say I make another variable, and I say int, I don't know, ty equals 0 or something. So notice how when I open this, also, if there's anything confusing, feel free to say anything. So notice what variables are being displayed here. We have checkbox, option, x, y, and z. But for some reason, we don't have ty being displayed. And that's because we haven't said it's public. So if we make it public and go back here, it should come up as one of the listed variables. Yeah, there we go. It's usually best practice to only make something a public variable if you're going to be changing it a lot. such as like player movement speed, just something you'd probably fiddle with a lot, typically. So anyway, let me move on to the other types of variables. So let me go on to Booleans. So Booleans essentially are just whether something is true or false. That's it. And what you can do with them, they're typically very useful in if statements. So what an if statement is anything within these two brackets. So anything within the two brackets, if that is true, then it runs this code block basically. So if this value is true, then run this. If it's anything else, then run this. So that's what an if statement does, and that's also what a Boolean is used for. Another example of an if statements that we could do, we could actually make use of our x and y. So what we could do is say if x plus y equals 2, then say well, x and y equals 2 is equal to 2. Else x and y is not equal to 2. So let me just run that quickly and see what happens. Feel free to answer any questions if anything's confusing, by the way. All right, so if I press play, it should just say x and y is not equal to 2. And as you can see, it does do that correctly. If I then change that value, so if I just make x1 and y1, you should be able to see that it says x and y is equal to 2. Also, oh, actually we have an error. Why is that? It's because we haven't set them in the editor. So whenever you make a variable public, just to remind you, it's bad practice to change it from the code itself. You usually want to do it from this screen, which I made that mistake just now. So 1, 1. Should be able to see that it is equal to 2 this time. There we go. Awesome. All right. So let me see. I think we've covered every type except for strings. So strings is very simple to set up. So if I just do public string text, right? I could literally just say debug.log string. That is the simplest way of doing it. If you want to represent any sort of text field, you usually just represent it in a string. One thing you actually can do, you can convert other data types into a string with a certain function. I'll go more detail into what functions are after this, but essentially what we can do is do, let's say we want to turn x into a string. All we say is x.toString, and that turns that into a string, basically. just wanted to check, Mr. Adewoye, does that make sense, the different variable types? So just to summarize, we have.
Yeah.
Makes sense. All right, I'll make a small summary though. So just to summarize, integers, we use int. Strings, we use string. Booleans, bool, and then floats, we use float, or decimals, we use float rather. All right, cool. So let me move on to switch cases. So a switch case is very similar to an if statement, but it's more on a case-by-case basis, for lack of a better word. So essentially, I've made this variable called option, right? An option is an integer. So what I've done here, so the switch case is based around that variable called option. So if option is equal to 1, then do this. If it's 2, then do this. If it's 3, then do this. If it's none of those, then do this, basically. Let me fix this quickly. One moment. But this is very useful in comparison to an if statement, because 1, it's faster, and 2, it's technically less hassle, because if I were to do the same thing in an if statement, I would have to do this. So I'd have to do if option equals 1, then do this, and then I'd have to copy this and do if else, like a bunch of times. And you can see how that's already getting a bit too much. So switch cases are very useful for when you have like one variable, but you want to do different things depending on its value, essentially. So that is if statements and conditionals, or if statements and switch cases. They're both called conditionals because like the code runs depending on the condition, obviously. They are very useful for, they're pretty much the backbone for most programming. So like being able to use them effectively is very important, in my opinion. Another thing that's probably the backbone is functions. So you probably saw that I've been programming only within these, basically. So let me clear this up a bit, just to make it a bit more clear. All right, so let me actually start with making a function. Oh, good morning, Mr. Adunga. Did you just join? I think your mic's unmuted. All right, so let me just explain what a function is. So a function is essentially an encapsulated portion of code. So if I made something called speak, right? Essentially, all this function does is hello. Actually, I already have a function like that. Yeah, so right here we have a function that says hello. So how does this work exactly? This function will only ever run if I call it. So what does calling a function actually mean? So to start off, I should probably start with the preset functions that Unity comes with. So what this does, what this function called start does, when I press play on Unity, it will run the start function, right? So that's just built into the program essentially. So what I can do, let's say I want to say hello when the game starts. So what we do is call our hello function, put it in start, and once we press play, it should say hello. So as you can see here, it's ran. So what if you want to run something more than once though? For that, let me actually declutter some stuff. Never mind. Okay. 1 moment. Yeah, so what if you want to run it multiple times? Well, Unity has another function called update. So what update does is it runs whatever is in the code block every single frame. So what's a frame? In games, essentially units of time are divided into frames. Typically, most games run at around 60 frames per second. So what that means is every 16 milliseconds or something, it does another step in the program. So think of it like it's doing 16 steps per second. So what update does is it runs whatever is in here every single frame. So if we want to say hello very fast, we can put our function here. And let us run this. And you can see that it says hello a lot of times. You can see already 1,000 almost. So this is very useful for, let's say, whether you want to move a character around every single frame, whether you want to jump. It's very useful for, like, actual gameplay. So typically you do start to set up your game, and then you'd use update to run everything. I'll go more into detail by showing you how I made those mechanics from last time. But for now, just know the difference between what start does and what update does. Is that clear to everyone? Just want to make sure everyone's following along. I've been talking for a while. Is that clear, Mr. Adunga? Or anyone really? If there's any issue, just tell me. All right, so you probably see that there's some other weird functions that I have here. So another interesting thing about functions is you can actually return a data value. So what does that mean exactly? Let's say I wanted to do this same addition thing, but I don't want to run it a bunch of times. Like, let's say I want to also add another set of variables like a plus b, or like just you want to do addition multiple times, but you don't want to have to keep typing in like the variables every time. What you can do is actually make a function that does that for you. So you can see here, I have this very weird looking function. So this first part is the data value the function is going to give back at the end of once it's finished running this code block, basically. So I've told it, once this is finished, return return an integer, basically. And here we have something called a parameter. So just to summarize, a function returns a value and can take parameters. So what a parameter is something that you put inside the function. That like a variable that you take into the function. So what you can do is say, because we want to take two numbers, we say we want integer A and integer B. They don't need to be named A and B. These are just generic names. So yeah, once we take those parameters in, we take that and simply add them together. And what this does return, it basically just returns that back to whoever asked for it. So if I go to, let me do this in start. If I say print out, oops, print out, I don't know, 3 plus 4 again. So we say 3 is our first parameter and 4 as our second parameter. So what happens if we do that? Let me remove the hello bit, just so that it doesn't run for too long. All right, let's see this. So you can see that we get 7 returned, basically. So you're probably wondering, what's the purpose of even using functions? It's basically to clean up your code and not make it too confusing, as well as allow you to reuse it multiple times in the function without having to copy and paste it multiple times. So yeah, that's the main purpose of it. There's a few examples of returning different variable types. So you see here, this returns a Boolean. You can see here that this returns a float. I might run this float one just to see a more practical example of a function. So let's say I want to half a number. So let's say I want to know what the half of 321 is. Now, no one's going to really know that off the top of their head. So I've simply designed this function to take the parameter that we've put in and then just half it, divided by 2. So if we run that, let's see what happens. Again, if anything's confusing, just feel free to tell me. So if we run this, we should get 160.5. All right, nice. And you can see that it's very simple to run. If you wanted to run it multiple times, instead of having to copy and paste all of this, we can simply repeat the function multiple times. So 301 or 546. Literally, yeah, it's just very easy, and you can see how concise it is, really. But yeah, that's essentially the main purpose of functions, really. I'll probably go on to object-oriented programming now and what that means, because it sounds like a very scary word. You can see that it halved all my numbers here. All right. So what exactly is object-oriented programming? So object-oriented programming is essentially a programming standard based on using objects and classes. Classes being a like blueprint for how to make an object. So what does that actually mean? So a good example that I can use is we take our player, right? So what we can actually do, we can actually have multiple players. Now, this isn't going to work well because yeah, it's just going to be very, very strange. But basically, we can have multiple players, right? But instead of having to make a new mechanic for each player, we can actually use the same scripts. So you can see here that our jump and our move script are on both of these player characters, right? So essentially, we can reuse the blueprint for our player, or we can reuse the blueprint for moving and jumping on several different objects without having to repaste code for each of them. So I'll go into a more formal explanation of object-oriented programming in this video. Let me just make sure that audio is working. Share audio. All right. Oh, why is it not? Okay. Tell me if you can hear this properly.
A popular interview question concerns the
Yes, we can. Just
four
increase the
concepts in
volume, please.
object-oriented programming. These concepts are encapsulation, abstraction, inheritance, and polymorphism. Let's look at each of these concepts. Before object-oriented programming, we had procedural programming that divided a program into a set of functions. So we have data stored in a bunch of variables and functions that operate on the data. This style of programming is very simple and straightforward. Often it's what you will learn as part of your first programming subject at a university. But as your programs grow, you will end up with a bunch of functions that are all over the place. You might find yourself copying and pasting lines of code over and over. You make a change to one function and then several other functions break. That's what we call spaghetti code. There is so much interdependency between all these functions, it becomes problematic. Object-oriented programming came to solve this problem. In object-oriented programming, we combine a group of related variables and functions into a unit. We call that unit an object. We refer to these variables as properties and the functions as methods. Here's an example. Think of a car. A car is an object with properties such as make, model, and color, and methods like start, stop, and move. Now you might say, but Mosh, we don't have cars in our programs. Give me a real programming example. Okay, think of the local storage object in your browsers.
Just to warn, this is not Unity related. This is a different program called JavaScript, but it's still the same concept in Unity.
Has a local storage object that allows you to store data locally. This local storage object has a property like length, which returns the number of objects in the storage, and methods like setItem and removeItem. So in object-oriented programming, we group related variables and functions that operate on them into objects. And this is what we call encapsulation. Let me show you an example of this in action. So here we have three variables: base salary, overtime, and rate. Below these, we have a function to calculate the wage for an employee. We refer to this kind of implementation as procedural. So we have variables on one side and functions on the other side. They are decoupled. Now let's take a look at the object-oriented way to solve this problem. We can have an employee object with three properties: base salary, overtime, and rate, and a method called getWage. Now, why is this better? Well, first of all, look at the getWage function. This function has no parameters. In contrast, in a procedural example, our getWage function has three parameters. The reason in this implementation we don't have any parameters is because all these parameters are actually modeled as properties of this object. All these properties and the getWage function They're highly related, so they're part of one unit. So one of the symptoms of procedural code is functions with so many parameters. When you write code in an object-oriented way, your functions end up having fewer and fewer parameters. As Uncle Bob says, the best functions are those with no parameters. The fewer the number of parameters, the easier it is to use and maintain that function. So that's encapsulation. Now let's look at abstraction. Think of a DVD player as an object. This DVD player has a complex logic board on the inside and a few buttons on the outside that you interact with. You simply press the play button and you don't care what happens on the inside. All that complexity is hidden from you. This is abstraction in practice. We can use the same technique in our objects. So we can hide some of the properties and methods from the outside, and this gives us a couple of benefits.
I just want to quickly state that when we were saying public, that was an example of showing it to like outside of the program. But if we don't say public, again, like int whatever, that is like private and is like not shown to any other program. So that's what he means by hiding variables or functions.
First is that we'll make the interface of those objects simpler, using and understanding an object with a few properties and methods, object with several properties and methods. The second benefit is that it helps us reduce the impact of change. Let's imagine that tomorrow we change these inner or private methods. None of these changes will leak to the outside because we don't have any code that touches these methods outside of their containing object. We may delete a method or change its parameters, but none of these changes will impact the rest of the application's code. So, with abstraction, we reduce the impact of change. Now, the third core concept in object-oriented programming, inheritance. Inheritance is a mechanism that allows you to eliminate redundant code. Here's an example. Think of HTML elements like text boxes, drop-down lists, checkboxes, and so on. All these elements have a few things in common. They should have properties like hidden and inner HTML and methods like click and focus. Instead of
I think a more easy to understand example would be something like, let's say you had an object called car, right? Now, variations of car, well, actually, no, let me start with again. So a car would have a function called like start, stop. It'd have variables such as max speed, acceleration, stuff like that. Now, variations might be things like, oh, it's a Mercedes or a Ford. So that's what they mean by inheritance. So even though they're different types, they all source from the same object called car, basically. So they all use the same functions like start, stop, blah, 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 but they're just different type, basically.
Defining all these properties and methods for every type of HTML element, we can define them once in a generic object, call it HTML element, and have other objects inherit these properties and methods. So inheritance helps us eliminate redundant code. And finally, polymorphism. Poly means many, morph means form. So polymorphism means many forms. In object-oriented programming, polymorphism is a technique that allows you to get rid of long if and else or switch and case statements. So back to our HTML elements example, all these objects should have the ability to be rendered on a page. But the way each element is rendered is different from the others. If we want to render multiple HTML elements in a procedural way, our code would probably look like this. But with object orientation, we can implement a render method in each of these objects, and the render method will behave differently depending on the type of the object we are referencing. So we can get rid of this nasty switch and case and use one line of code like this. You will see that later in the course. So here are the benefits of object-oriented programming. Using encapsulation, we group related variables and functions together, and this way we can reduce complexity. Now we can reuse these objects in different parts of a program or in different programs. With abstraction, we hide the details and the complexity and show only the essentials. This technique reduces complexity and also isolates the impact of changes in the code. With inheritance, we can eliminate redundant code, and with polymorphism, we can refactor ugly switch case statements. Well, hello, it's me, Mosh, again.
All right. So although not all of it's relevant because it's a different programming language, these four pillars are relevant to all object-oriented based languages. So that's C# in our case. Just forgot to mention that actually. So C# is the main programming language of Unity, basically. But other programs such as Java or C++, they're also object-oriented based programs. So yeah, is that. Does that make sense to everyone? Does that make sense, Mr. Adewey?
Yes.
Do you understand like the differences between each pillar? Let me actually link this as well, because this channel is very useful for learning these type of concepts. So I'll just put that in chat as well. All right, so let me actually show how I made the scripts from last session to give a more practical example to what I've been talking about. So let me delete this. Let me show how we got our player to move, for example. So if I open this, we have quite a lot. So when making this, I was thinking, okay, what do I actually need? I need how fast I want the player to move. I need inputs from the player, so whether they press left or right on their keyboard. I need to find out the direction to move the player based on whether it's left or right. And then I also have the rigid body. So just to remind again, the rigid body is the like handles the physics for that object, basically. So what I've done here is I've said set our rigid body variable to be the component on our player. So what this does, get component, says, okay, look through our object, which in this case is our player, and look for anything that's a rigid body 2D, which is, again, this. You could also do things like transform. So you could be like, okay, what is our position, rotation, or scale? You could do transform. Let me change it to trans. Let me do trans equals get components transform. And that would look through our player object and set the variable trans to be the one on our player object. So that's what we ran at the start of the program, basically, just saying, okay, this is our physics handler. And you'll see why I refer to that later, basically. Now, here I have a variable called input x. So that's essentially, I've named it input x because I want to see the left and right inputs on someone's keyboard. And you can see here I have something that says input.getAxis horizontal. Now, what does that mean exactly? So in Unity, you can actually predefine inputs. So what does that mean exactly? So if I go here, Let this load a bit. If I go to edit, project settings, input manager, and I open this axes thing. So what you can do is say, so instead of saying, let me show an example. Instead of saying something like input.get key, A, for example. Good afternoon. What I can do, so let's say what you'd end up normally doing is going, if I press the A button, then do this. And if I press the D button, then do this. Well, the problem with that is you have a bunch of if statements going around. But what if I also wanted to use the arrow keys? Suddenly you'd have 4 different if statements. So what Unity kindly does is let you predefine an axis. So basically, what I'm saying here is that if they press left or if they press A, or A, set the value to be -1. If I set it to be, you can see here our positive button. If I set it to be right or D, so right or D, set it to be 1, basically. So Unity is very kind and lets you just kind of set like a scale, basically, based on what button they pressed. And it lets you just put all of that in like one line of code. So I actually didn't make this axis. This comes predefined with Unity. So if you've installed Unity, you can actually just type this and it'll work immediately. So does that make sense? If there's any issues, just tell me. All right, so let's move on to actually moving. So what we can actually do to move it in the real world, I need to talk about what a vector is. So let me go back to my program. I'm sorry, I don't know why it always is taking this long to initialize. It doesn't normally take this long. So let me actually open my scene view to explain what that means. So a vector is essentially like your 3 points in space. So you have your x-axis. Actually, I can probably show it better in the program. Make a cube. Yeah, so we have our 3 axes. We have our x-axis here on red. We have our y-axis here in the green, and we have our z-axis here on the blue. So what we do in our case is that we don't actually use this z-axis. So if you're using 3 axes, you use something called a vector 3, which is just 3 floats or 3 decimals that define a position, or it can define the speed of something, depending on what you do. I'll be very brief about vectors for now because they can be a bit complicated, but just think of it like a list of, in our case, 2 numbers. So the x direction and the y direction. So if I go back to here, it's simply the x in red, so the left and right, and the y, the up and down. So just think of it like that, basically. So what am I doing here? So what I'm trying to do is I'm trying to set the direction that the player should move, depending on whether I press left or right. So what you can do is say, multiply the movement speed by the direction I've pressed. Actually, let me separate this quickly. So, as I said before, how a vector 2 is two floatings, or two floats. So if I say 2.35 and 50.6 or something, that's how you define a vector, right? So what I've done in this case, I have my floats move speed and my floats input, and I've just multiplied them together in this first parameter, basically, or in this first section rather. And then the second one, I've simply put the player's fall speed, basically. So when I press left and right, I don't want it to affect how the player is falling. I only want it to affect how it moves left and right, basically. And then after we've done that, we simply say, okay, so your velocity is this, basically. So I'll probably show it in the console just to actually show what's happening. All right. Again, if anything's confusing, feel free to ask, just because it can be pretty confusing. All right, so you can see that I've set my movement speed to 4.5, and what's it called? These are just here to show you the values changing, basically. I'm not actually meant to edit them. All right, so if we start this, you can see we get a lot of text being output. So what exactly is this? Let me restart it. So because I'm not pressing anything, and we go back here, remember how I probably should have mentioned on the axis, if I don't press either, the value is just 0. So so the value is 0. So what's happening is input x is 0 because I'm not pressing anything, and I'm timesing it by our 4.5 here, basically. So if this loads, you can see that it's just a bunch of zeros in our first section. Now, if I were to press left, you can see that it does minus 4.5. Now, again, if I press A or left, input x becomes -1. So it simply becomes -1 times 4.5. And that's how we get this result. If I press left, if I press right, it becomes 4.5. And you can probably see that the second section, let me just pause this. See that the second section changes when we like fall, basically. So if I just continue that, you can see that oh, hold on, something is not working. Oh, yeah. You can see that it starts to turn negative because I'm falling down. If I were to jump, you can see that it increases, right? So because I'm going upwards, it's a positive value. If I'm falling downwards, it's a negative value. So that is how I've programmed moving left and right. For jumping, it's a bit more complicated. In fact, a lot more complicated. So I won't go too into detail. So again, we've stated our physics handler. And again, we are using an axis. So what does the jump axis actually look like? Oh God, that's the wrong thing. So edit project settings axes. This is again another predefined axis, and Unity defines it as so. So if I press space, put the value at 1. If I don't press anything, it's just 0. You could add another button if you wanted to, but for now, I'm just going to keep it simple and use space. So what does all this mean? I won't go too into detail, but one thing I forgot to mention about if statements that is different from switch cases is you can actually put multiple conditions in one if statement. So what I have here is basically if this statement is true and this statement, so if you put an exclamation mark in front of a Boolean, it inverts the value. So if I have a variable, if I have a Boolean that's true and I put this exclamation mark symbol in front of it, it becomes false, basically. So what I've said here is that this is true and this is false, and this statement is also true. Run this, basically. This is pretty complicated stuff, but just imagine if I'm on the ground, the way I've made it is if I'm on the ground and I've just landed and I'm not currently jumping and I'm pressing the jump button, then jump. That's a very simple explanation, but that's essentially what's happening. I'll go more into detail about how we actually jump. So rigid bodies have a function that you can call called add force. So I should probably explain a bit how you call functions like this. So if I go back to basics, right? Remember before how I said that you could also make variables public. You can actually do the same with functions. So if I do public void, so void means we're not going to return anything at the end. If I do public void speak, let's just make it a very simple function. And all we're going to say is, yeah, just say something random. Hello world. So let me also show a brief example of object-oriented programming. So because this class is public, I can actually also use it in another program. So what I can do basics. What's it called? Called basic. So classes basically allow you to refer to them in other places. So kind of think of it like we're making another variable in a way. So we're making our own custom variable, but it has its own functions and its own variables inside of it. It's a very brief explanation, but try and think of it like that essentially. So what Unity's done is that they have a class called rigid body 2D, and they have a function called add force. So in our case, we have a function called speak, and what you can do is this. You can be like basics.speak, and that's how you call a function from a different class, basically. And that's a very brief explanation as to why we're able to call a function like this. Yeah, very brief, but that's the best explanation, basically. So how do we actually jump? So again, referring back to classes, Unity has a class called vector2 that, if you look here, I don't know if you can see this. Yeah, so this class has a preset variable for the up direction, which is simply 0 on the left and right, and then 1 on the up and down. So basically, when I write this, all I mean is this, basically. It's just shorthand, basically. Yeah, so it's just shorthand for that, basically. So what we're doing is we're multiplying the up direction by how hard we want to jump, basically. And so what you can do from there is define the type of force. So in our case, we want it to be instant. We don't want it to be like a long jump. We just want an instant upwards force. So that's why I've defined it as force mode impulse. There's also other ones, but for now, we just want to have an instant upwards force. All right. So let's see this in action. So yeah, again, you can see our jump strength, with the spacebar is pressed, and then again, our conditions, whether it's landed or whether I'm currently jumping. So if we see this now, you can see that we are currently on the ground. I'm not pressing anything. So if I were to press space, you can see that it's been set to 1, which means I'm holding the space button and I'm also jumping, essentially. And if I don't press anything, you can see that I've now landed. The way detecting landing works is a bit complicated, but think of it like this function detects whether I'm on the ground or not, basically. So that's how I've programmed that. The other ones are a lot simpler. So if I were to show those, I'll start with the death trigger. So one of the mechanics we stated before was if the player falls, restart the game. So how would I do that exactly? So you may have remembered that before I talked about how a collider can also be a trigger for something. So if I check this as a trigger, it gives me the capability to use this function called onTriggerEnter. So when something enters this space, like this space here, then run this function, basically. So in our case, if something enters and their tag is player, so what's a tag? If you click on an object, you can actually set a tag. You can make your own, but for now, I've just set it as the player. So whenever, just to summarize, whenever something passes through this and their tag is player, then run this. So this script here essentially just reloads the selected level, basically. And so that is actually how we install that mechanic. Very simple. You actually don't need any of these functions. You just need this. So yeah, around 5 lines of code just to have a simple restart function. So onTrigger is a good example of why functions are useful, because I actually use this function again on our win condition, which in this case is the door. So if I come here, you can see that I use onTriggerEnter again. I check if it's the player, and then I run this piece of code here. So what does this do exactly? When I start the game, find me an object in this hierarchy that has the tag windscreen. So what's the windscreen exactly? You can see that this level complete UI here has the tag windscreen. So basically, I don't want this to show during normal gameplay, but once they've hit the door, I want it to appear. So one thing you can do, so once we found our windscreen, we actually want to turn it off so that the player doesn't see it by using something called set active. So what set active does, it basically uncheck marks this from the scene. So you can see how it's gone gray here. So yeah, when it's not active, it can't be seen, it can't be interacted with, it almost doesn't exist, but you can reactivate it by using set active equals true, basically. So if I reselect that, set active essentially just uncheck marks and checks marks an object in our hierarchy for us. Very convenient. Yeah, so that's how the win and restart, that's how our lose and win conditions work. A lot more simpler than our movement and jumping scripts. But yeah, also, by the way, all of this is provided in the code I linked to you in case you want to look at this in your own time. Because I know I've been talking about some pretty complicated concepts very briefly. But yeah, hopefully a lot of what I've told you has helped you kind of think how you might be able to make your own mechanic. So what I want to actually try and get you guys to do is just add one new mechanic to this game. It can be to the player, it could be to the door, it can be to our lose condition, but just one script, basically. It can be as simple as addition, multiplication, just some sort of additional component to the game. So if you need assistance, I highly recommend using these websites. So let me actually explain what these are. All right, so I think the main ones I'd say are the Unity documentation. So I think of this as the Unity Bible almost. It explains every single thing in Unity. Every single like window, every single option, it's all here basically. So if you have any issues or questions about something, so a good example would be how I've done this jump. So what is raycast hit 2D? I don't understand what that means. So you just go here, search for it. Oh, hold on. Sorry, I've ringed the wrong thing. It's actually the scripting reference, not the manual. Yeah. So what exactly is raycast hit 2D? Just go here and it should give us a full documentation. So if I click this, it tells me all the variables in this class. So you can see we have things like collider, distance, and it explains what it is. And it also refers you to some other use cases of using that. It can even be something as simple as what does the start function do? Hold on. Something simple as like the start function or updates. Wow, there's a lot of start functions. But basically refer to this if there's any questions about stuff. You can actually also in the program itself, if you click the question mark, it actually opens the manual or the page to that object. So if you want to know how to use a collider properly, all the options, what each text field does, you can just click that question mark and it directly links you. It's very convenient. If you want more specific questions, I recommend using Unity Answers. So what this does is basically just a forum of people who also use Unity, and a lot of common questions you may have are probably on Unity Answers. So if there's some sort of issue or bug, this is highly recommended. The last one is if you're having a more coding specific issue, is Stack Overflow. So Stack Overflow is another forum, but I'd say it's a lot more coding focused, and it's very useful because a lot of professionals use this site and can give you some assistance in answering some common coding issues. But the last and most important one, in my opinion, is just Google. I've learned so much just from literally searching up any sort of error or issue I was having. Yeah, you could honestly, most of programming or learning game design is just looking it up, just because there are probably thousands of people who have also had the same issue. And there's, again, the same solutions are just out there. Yeah, so if you're having any issues with trying to add this new mechanic, I highly recommend just using some of these resources. I'll actually just link these in chat, just so you have the direct links. Oh, I've been direct messaging, sorry. Yeah, just to link these to everyone in chat. Stack Overflow and Google. All right, so that should be everything that you need. Are there any questions about anything? Mr. Adewoye, did you have any questions, or Vincent? Any issues you had? Anything confusing?
Yeah, so for now, I don't have any questions to ask you. But the thing is, I told you that I'm not with my laptop. So once I start my coding, then like I'm going to be disturbing you. Like I will just collect your contact so that we can chat.
Yeah, so this will also be a recording, so you can also watch back what I've talked about when you're at your laptop as well. But yeah.
Okay. Thank you, sir.
Awesome. I hope this has been useful. Just to conclude, today we covered what an IDE is, what variables, if statements, switch cases, functions, and what object-oriented programming is, and also linked a few different common coding resources that you can use. But yeah, coding can seem pretty daunting, even from like all of the stuff I've just explained, but it honestly gets easier the more you practice, honestly. But yeah.